So in this video, I'm going to show you how to solve a system of equations using graphing. And the equations that we're going to graph and find the intersection of are right here. And again, always when we start a problem, we should take a look at the problem and just make some observations about what we're being asked to do. What I notice is this equation is the equation of a line. So at some point I'm going to be graphing a line on my axis. And this equation is the equation of a parabola, a quadratic equation. And I also notice that it opens down. This negative in front of the leading term tells me that my quadratic is going to be opening down. So when I get done sketching, I'm going to have something like a downward opening parabola and a line intersecting, and I'm going to want to know where those two equations intersect. So the first thing I do is I graph my line. And you can graph the line in many different ways. One of the ways to graph a line is simply to find 2 points that are on the line and then connect the dots. So I'm going to go ahead and do that. I'm going to substitute 1 for x, and then I'm going to do a little bit of algebra to find out what y is. So I'm going to subtract 1 from both sides. And I get -3, and that tells me I have a point at 1, -3. So I can put that point on my graph now. And then I'm going to go ahead and say, well, what about when x is 0? What would y be when x is 0? And it looks like y is equal to -2 when x is 0. So there's the equation of my line. And what I want to do when I graph a system is I want to be as picky about my graphing as I can be. And so I'm going to use a ruler to sketch in my line. The next step is to get the quadratic on the map, and then we can see where they intersect. So I'm going to graph a quadratic using the normal technique of finding the vertex and then finding the zeros if there are any zeros. Keep in mind we could have a quadratic that never does touch the x-axis, so we would have to use some other method for graphing it. But I'm going to first find out whether this one has zeros or not. So I'm going to find the vertex, and that is at -b over 2a. And so this gives me -2 over -2, which sorts out to be 1. So I know I have an axis of symmetry right here where x is equal to 1. And let's go ahead and find the y value of the vertex. So I'm substituting that 1 in for x. And I get -1 plus 2 plus 8. So it looks like the y value of my vertex is actually at 9. So my vertex here is at 1, 9. And I'm going to go ahead and put that on my graph. So I have my vertex, and now I'm interested in finding the zeros. And it looks like we are going to have zeros because my vertex is above the x-axis and it opens down. So to find the zeros, I'm going to factor the equation. And the first step in factoring a quadratic that has a negative in front of that x squared term is to factor out a -1. Oh, and notice that when I do that, it changes the sign in front of the 2x and in front of the 8. So I've factored out my -1, and now what I need to do is I need to find factors of -8 that add up to -2. And when I do that, I find that I get x -4 and x plus 2. And let's just go ahead and check and make sure that we're right on those factors. -4 times 2 is -8, so I'm pretty happy with that. And then -4 plus 2 is -2. So I think I'm factored appropriately, and this tells me that the x value of my roots is at 4 and -2. So right there and right there. And now what I notice is that my parabola and my line both go through this point at -2, 0. And that gives me a really big hint that that is probably one of my roots. But what I notice here, and sometimes it's a little difficult to graph this quadratic really, really definitively. But what I notice here is that I think I'm intersecting at -5, maybe this is 5, 6, 7. I'm kind of guessing that this is an intersection at 5, -7 on my graph. But notice I've run kind of all the way off the graph, and it's a little bit difficult for me to tell whether or not that's actually a point on the graph. So the way to determine whether it is or not is to check it. And I need to check it in both equations. So I'm going to take this 5, -7, and I'm going to go up to the linear equation and plug in 5 for x, and I'm going to plug in -7 for y. And when I make those substitutions, I notice that I get -2 equals -2. So that tells me that this point is definitely on my line. Now I need to know that the point is definitely on my parabola. So I'm going to plug in this point, 5, -7. So I'm going to plug in -7 for y, and I'm going to plug in 5 for x. And let's see, here I get 25, but it's negative, plus 10, plus 8. And that should equal -7. And so when I sort out my arithmetic here, I see that I do in fact have a true statement. And I've just proved that this point is also in the quadratic. So I do have an intersecting point right here on my graph at 5, -7. So I've found the two solutions to this system of equations by graphing.